Assalamu alaikum, how are you, grade 7? I miss you too much. Let's start our last lesson in this unit, electric current make magnetic field. Our outcomes, describing the field of an electromagnet. Second, relate between current and field. So welcome aboard with teacher Manal Abdelhadi from Umariya School. Let's start. Let's talk about story of electricity and magnetism. There was a Danish scientist. His name was Hans Christian Ørsted, or his short name was Ørsted. He discovered the connection between electricity and magnetism. So in 1820, he was giving a lecture about electric circuits, and he was doing an experiment with one of his students, as this one. When he just suddenly noticed that when he switched on his circuit, then he noticed that the compass needle changed direction. Now what he concluded? He concluded that whenever an electricity current flows in a wire, it makes a magnetic field around it. So as you can see here in this circuit, this is a compass. It's always direct to the north and south. What will happen when we connect the circuit, or when close this electric circuit and the current flows in the wire itself will make a magnetic field around it. How can I know that? Because the compass changed its direction towards the wire. It means that there is a new magnetic field produced from the wire itself, because the electricity flow in it. Of course, it is a temporary magnet, or we call it electromagnet. The wire itself behaves as a magnet. We will use what Ørsted found in a straight wire. He said that the electric current flows in that wire. It makes a magnetic field around it, but that magnetic field in the straight wire, is quite weak. So what did we do here is the following. We used a coil of wire to make the magnet stronger. So here an electric current must flow through an electromagnet if the magnet is to work. So we should have an electric current in this electromagnet. So here, by winding a wire of coil, the magnetic field is concentrated into a smaller space, making it much stronger. So instead of using only one straight line of wire, or one straight wire, we are going to use a coil of wire. This makes the electric field around it and inside the coil much stronger than the straight line or the straight wire. So this coil of wire has a magnetic field around because the compass itself changed its direction towards it. Because normally the compass point towards the north and south directions. But if there was a magnet around it or close to the compass, it will change its direction towards the magnetic field lines. Let's make an electromagnet circuit. In this way, this is the positive pole of the battery that the current coming out of it towards the coil. Then this side the current will go out towards the negative pole of the battery. When the current flows inside, a magnetic field is produced around this wire or around this coil and inside the coil itself. Let's see here. We have a bigger image here. The current is coming inside the coil from this side, so this is the south pole, and the current going outside from the coil from this side, so this is the north pole. And also there is another way to know the north and south pole, by looking at the magnetic field lines. So it's coming out of north and going towards south. So it's so simple. We can only look at the current direction, where is it coming from, or coming from the battery from this side, for example. So this is the south and the other is north. And the electric field lines coming towards the south, going out from the north. So it's so simple. Look at one of them. Look at the current, you can know the poles, or look at the magnetic field lines, you can know the poles. We have another way to represent the coil of wire. We have here a positive pole of the battery, we have a negative pole of the battery. Now, depending on the coil direction, we have the current coming inside the coil from this way. So this is the south pole. And the other direction that the current flow away or outside from the coil is the north direction. And also the magnetic field lines can help you to know that. So it's going out from north and get towards the south. Now we have a question, mark the poles. How can I mark the poles of this coil of wire? Let's see. We have many batteries here, and this is the symbol of the battery. We have positive pole, negative pole. Now you have to concentrate on the positive pole first. The current will get out from the battery towards the coil. So this is the south pole. What about the other part, that the current going out of towards the negative pole of the battery? This is the north pole. There is another evidence, not only the battery poles that can show you where is the south, that is next to the positive, and the north next to the negative. There is also the magnetic field lines can show you where's the north and south. So these lines are coming towards the coil. Okay, so this is the south pole. And the other lines here going outward from the north pole. And these curved lines are going from the north towards the south pole. Now let's see, we have our course book, question number 1, page 172. Mark the places where the magnetic field is stronger. So where's the magnetic field stronger? That's our answer, with the regions that are nearest the north and south pole. So these parts here, or these regions nearest to the north and south poles, have more magnetic field lines. It means that the magnetic field is stronger here, or near to the pole, you can answer. Now question 2, page 173. The diagram shows the magnetic field around the wire when a current flows in the wire. This is a straight wire here. And these green circles are the magnetic field around it. So what shape are the magnetic field lines? You can see here, they are circles. Okay? Now what about part B? Where's the magnetic field the strongest? Explain how you can tell from the diagram. So here we have the magnetic field around the wire with an electric current flowing in it. What about the field? It is the strongest actually close to the wire. Why close to the wire? Because these circles are closest together near the wire. So that's the reason. When we go away from the wire, actually the circles are away from each other. So it means that it became weaker. So it became stronger and stronger when we get closer to the wire. Now please highlight our lesson. Alhamdulillah, we are finished. It's a short one. Electric current make magnetic fields, page 172. Sorry for making a photo from my book, but the PDF do not have this lesson. So the field of an electromagnet. The magnetic field of an electromagnet is like the field of a bar magnet, and that's the description of it. And here we have current and field. We started with this story about Ørsted, that he found the connection between electricity and magnetism, and how he did his experiments, and that's approach actually for his experiment. Here it looks like a comparison between the wire used by Ørsted, and it is a straight wire, the magnet is quite weak, but in electromagnet we used a coil of wire that make the magnet field stronger. And concentrate on the summary, of course. Thank you for today. That's all. And this is your homework, workbook page 128. I hope you enjoyed the lesson as much as I enjoyed it. Thank you. Have a nice day. Take care.